Yeah, so today we're going to talk about something that we struggled a long time about what to call this. We finally decided on the term National Hydrographic Infrastructure, or NHI. And that's because it really is what we are envisioning this as, really an infrastructure that people will use sort of like the road network just to tie things to. It's an information infrastructure, not a physical infrastructure. But so think of it a lot like the underpinnings of, you know, of Google Maps or GPS that has embedded maps. That's what we're envisioning as this National Hydrographic Infrastructure. So basically, we're trying to combine, you know, this foundational hydrography and data sets that we have with the capabilities that they have of addressing, and then also building a search engine and a catalog so that people can use the intelligence of the hydrography network as part of a search functionality. So kind of building a search engine that understands the hydro network. And so our concept here is to provide this infrastructure for sharing data, any kind of water, surface water related data. That would basically be kind of underpinning all different agency efforts that have hydro observations and modeling, and just basically trying to account for all the water in the hydrologic cycle. You know, going from when we get water falling out of the atmosphere onto the land and where it goes out into the ocean again. So all of the land part of that water cycle. I will, there's this diagram which is kind of complicated. I'm going to talk about it in very general terms, and I'll show you on the next slide. I'll show you this more so you can read what's under here. But basically, we're going to talk about this hydrographic framework, the hydrographic addressing tools, how that relates to the community and how the community can make use of this, and finally, these tools for catalog, search, and discovery. So here's that figure a little bit more enlarged. And the first category down there in the center is the framework, the hydrographic framework, and that basically consists of the data sets that we've used for many years, the NHD, the WBD, and the 3DEP. Now we're combining those together into the NHD Plus high-res. Excuse me. So that's our basic framework. And then we are going to spend quite a bit of time today talking about addressing. So the term that we've used in the past, which is kind of a jargon, a GIS jargon term of events and linear referencing, we found that people just didn't understand what that meant if they're not a GIS expert. They didn't understand what we're talking about, but we could talk in terms of addressing as a verb and addressing things to the network, and people understand intuitively what we're talking about. So we're talking about these addressing tools, and we have some web services and this engine, addressing engine, underlying those tools. So we're going to talk quite a bit about those tools today. So that's hydrographic addressing. Next, you know, once you've addressed your data or your points of interest to the hydrographic network, you can publish your data as a web feature service. And then the concept here is that we have out in the community, everybody still maintains control of their own data set. They're not making copies. We're not storing copies of your data in our database or anything. You would control your data. You would have your data itself, but you would just serve it as a standard OGC web feature service with particular fields in there. There's a minimum set of fields that you would need to have in those data sets, and then you could participate in this NHI framework. And so you would have all your different data sets shared out here, and then those would feed into a catalog, and then based on that catalog, we'll have search and discovery tools and, again, web services. So this whole structure is a web-based structure. So moving from the desktop, where we've had similar functionality for a long, long time on a GIS desktop, primarily in our HEM tools working inside ArcGIS, this is opening that whole power up to a web-based infrastructure, a web-based paradigm. So people don't have to have software installed or anything. It works in a standard web browser. So let's see. Becci Anderson is going to talk a little bit about governance as it relates to the National Hydrography Infrastructure. Becci, are you on?
Yep. Excuse me, yes, I'm here. And just a note for the other presenters, it seems like there might be quite a lag in especially animations in the presentation, but also maybe even just switching slides, just a note. So the National Hydrography Infrastructure Working Group was started up, I believe it was in the fall of 2018. And this group primarily focused on moving forward with the National Hydrography Infrastructure, all the parts and pieces. Right now, it consists of all of the federal agencies that you can see in the list there. USGS co-chairs the group. We've been meeting quarterly, but we are moving to meeting every other month as we move forward to develop goals. This group really acts as a hub. There are not only the different agencies that participate in it, but there's also programmatic and technical advisors, especially from the USGS. These are people specifically from especially National Geospatial Program, but also Water Mission Area, who help to advise, since so much of the NHI is being developed at USGS right now. We also have at least one kind of subcommittee. It's a subgroup, is what we call a sub-working group, and that's on addressing. So we'll hear a little bit more about addressing in a minute. And that group is composed of technical people from the agencies that are part of the larger group. And they're focused right now on looking at, I don't want to use the word standards, but standard ways of doing things and models, so that we're all doing addressing in similar ways. We're all figuring out how to attach the information to the hydrographic framework using similar methodologies that are in particular interoperable. We also coordinate out with other governance groups. SSWD right now isn't meeting, but we also meet with, we coordinate with the 3DEP working group and the FGDC National Geospatial Data Asset groups. So right now, as I mentioned, we're really looking at goals, and I think the next kind of pieces of work we'll focus on are the next steps in NHD plus high resolution production, the structure for that, as well as elevation derived hydrography, how to get the streamlines from the elevation data and move that into the NHD to get a more robust network that's better aligned with elevation data, as well as moving forward further with hydrographic addressing. So Al, I'll hand it back to you.
All right, great, thanks, Becci. So this is hopefully a review for most folks on this call, but you all know that we have a linear referencing, hopefully you know we have a linear referencing system built on top of the NHD of reach codes and measures along those reaches, starting at 0 at the bottom, the downstream end of the reach, going up to 100 at the top of the reach. These really are, you can think of these as analogous to a street address. So if you had, you know, your street address on a map of showing the streets. Then we also have the watershed boundaries data set, which sort of provides more of a larger, they're really used as reporting units for the most part. And it's a hierarchical structure of nested data sets, polygons, and you can think of those really like zip codes. The analogy breaks down a little bit if you get into the super detailed analysis of it, but it's a good way just sort of in general to think of these things, especially if you're trying to talk to people who aren't already familiar with these data sets. So that's one thing one way to think about it. So a little bit more about the linear referencing. So we'll have something that we want to reference to or address to the data set, to the NHD. So we've got, for example, we have this stream gauge that sits right here, and it's maybe on the bank of the stream. It doesn't sit exactly on the network. So the first thing we have to do is sort of snap that over onto the flow line network of the NHD. This process can actually be, you know, this snapping distance can actually be quite long if, for example, if you have a wide river. So that can, you know, but the important thing is we want to know where this gauge sits functionally on the network. So what's it measuring, and what is that, how does that relate to the stream network itself? So then we're in essence, we're converting from latitude longitude coordinates to a reach code measure pair of coordinates on the network. So that gives us sort of locational or geospatial context to the data. So if you have this data here from the gauge and you're wondering, you know, what's going on here, why does the data look the way it does? Well, a big part of that is probably because we're sitting just downstream of a large reservoir, right? So it's a regulated flow here. So all of that information about where you sit on the network really enriches the information, the data that you may collect at that place, because now you know, okay, I'm downstream of this large reservoir, maybe there are withdrawals coming from the reservoir, it's regulated flow, and so forth. Really kind of underlying all of this is the ability to do navigation on the stream network. And we've traditionally, we've enabled this function in the GIS desktop using the geometric network, Esri geometric network. I'll do just a quick little sidebar here. I don't want to spend a lot of time on it, but the geometric network does not work in our GIS Pro. However, there is a new data structure that Esri's developed that they're calling the trace network, which provides all the same kind of functionality that we have with the geometric network. And that is out in beta right now. We have tested it, and it will be released in the summer when Esri releases the 2.6 version of ArcGIS Pro. So we've done some testing on that, and it all seems to be working really well, and it works very much like the geometric network does in ArcMap. But the thing about that is it's relying on a proprietary data structure. It requires that you have GIS desktop software, basically, in order to use it directly. So what are some other ways that we can do network navigation? And we've developed this set of attributes called value-added attributes, or VAAs, that are part of the NHD Plus. They're part of NHD Plus medium resolution that's been around for a long time, and are also part of the NHD Plus high resolution. And this set of attributes here over on the right are all involved in one way or another in network navigation tasks of one type or another. The nice thing about being able to do navigation using attributes is that it basically boils down to a database query, something that's very easy to do over a web service kind of thing, and it's not reliant on proprietary data structures. So that's a big advantage of being able to do network navigation with the VAAs. Here are some resources, and I'll make this PowerPoint available afterwards with these links. We have a web page on VAAs that explains them much more completely. Our user guide, if you haven't seen it yet, for the NHD Plus high res, we published that just a couple of months ago, actually sort of over the holidays. In that time frame, we published that. It's got a lot of information in there about VAAs and how to do certain tasks like network navigation and so forth. We also have a kind of tutorial and a workshop that we put together. We have that out on GitHub. So it's got a network navigator, a VAA network navigator. It currently runs just for ArcMap. It's an executable that you can download. It does upstream main stem, upstream with tributaries, downstream main stem, and downstream with divergences. Does all those 4 types of navigations. We also have source code in that GitHub repository. There's a toolbox with an ArcPy module that does upstream with tributaries, I think, for ArcGIS Pro. So we don't have a complete set of tools yet for Pro, but we do have some of the tools here. And then there's more information on our webpage, of course. So I want to also show, this is a prototype that is actually a functioning prototype of the web-based services that we are trying to enable for the NHI. This is all based on NHD Plus version 2. And this is live right now. You can use the URL that you see up there at the top and then add to it navigate upstream main stem, and you'll get returned the features that are upstream of that point that was specified here in the URL, which is a HUC12 pour point, the outlet of a HUC12. And this is the HUC12 that we're looking at, which is in Central Florida. You can do a navigate upstream with tributaries, and you get all of the flow lines upstream of it. You can also do a downstream with divergences. Here's that zoomed in. You can also do downstream main stem. All of these things work. Basically, they're restful. It's a RESTful API. You can go to these services and execute these things directly if you want to. Again, this is based on that NHD Plus version 2. We hope to build this out based on NHD Plus high res in the near future. But the real power of this is not just being able to see the hydro network, navigation on the hydro network. It's actually finding things that have been tied to that network, linked to it or addressed to it. So here we have an example where we do an upstream with tributaries from that same place that I showed earlier, and we look for the NWIS sites, so that the USGS NWIS database. So not all of the NWIS sites are indexed in this data set yet, in this catalog, but most of the gauges are. And then here we have sites with water quality. So there's something called the water quality portal that this is embedded in. The water quality portal basically aggregates data from about 400 different databases, including USGS's NWIS database, EPA's STORET database, and a whole bunch of databases from other agencies and state and local agencies as well. So this already working in the water quality portal. And just to give you an example of how this can really empower things, we had an example back in August of 2015 where there was a spill called the Gold King Mine. It spilled mine waste into the Animas River. And what you're seeing here is a model that was used to estimate travel time of the plume going downstream. Each of the different colored segments are 1 day going downstream on the Animas River. So we had a request from EPA to get all of the historical water quality data downstream of that spill. Well, our databases were not set up for that. And it took us a couple of weeks and several conference calls for a team to actually compile all of that data. You can do that same query now using the water quality portal and this sort of thing in a couple of minutes. Actually, if you were to click on this, it would go actually way less than 2 minutes. So that's the power of having this sort of infrastructure. This really is an implementation of the National Hydrography Infrastructure. So, you know, it's this stuff here over in the corner of the catalog, the addressing, search, and discover data sets, search and discovery engine. So the next couple of segments of this are going to focus on the addressing, hydrographic addressing, and focus on tools that we have available now or in the near future for you to use to address data to the NHD. And with that, I'm going to turn it over to Daniel Wieferich. Daniel, can you kind of introduce yourself and talk about the Hydrolink tool?
Can you hear me all right?
Yes.
Okay. As Al mentioned, I'm Daniel Wieferich. I'm with the Science Analytic Synthesis program within USGS, and I've been collaborating with NGP and NGTalk on the NHI and linear referencing concepts over the last few years. Today I'll be talking about the Hydrolink tool that my program developed with support of the USGS Fisheries program. And I'd like to note right away that throughout the presentation I'll be providing some direct URLs, but the URL on this initial slide here will actually get you to all the other URLs and everything that I'm talking about. And I'm actually sharing that in the chat right now as well. Next slide. So one of the main drivers of the Hydrolink tool was to help encourage USGS scientists and our partners to linear reference and or address their data to two commonly used versions of the National Hydrography dataset, and then to share that information as a common resource to start building up our collective knowledge of the stream networks. I won't go into a lot of details here, but on this slide we have some of the specific national efforts from my work that contribute to this concept and also illustrate the power of having many habitat and fisheries data sets addressed to the same stream network, allowing us to better model species distributions and habitat conditions at large spatial scales. or in my case, at the national scale. Next slide. So to build off my last slide, the Hydrolink tool was built to support researchers in the verification of point data locations and to support them in linear referencing or addressing of those points to the NHD Plus version 2 medium resolution and the high resolution NHD as well, which are in my field of work, two very commonly used hydrography networks at this point. Although this was supported by the fisheries effort, it can be leveraged for any sample site data or spatial feature locations related to streams, and is available to most ArcGIS Online account holders. The tool was built to require a point-by-point editing, and this was to encourage scientists to evaluate site locations and the NHD quality. And on the NHD quality end of things, you know, our scientists across the agency are out in the field. They've got a pretty good understanding of the hydrography, and we're hoping that with a little bit of encouragement that we could bring that knowledge back to the NHD through the markup tool or alike. But having folks go through and look at one point at a time as they address, it brings up and shows potential different issues with the NHD that can be updated through time, and then we're improving on the network and the quality or the capability of using this information through time. Next slide. The Hydrolink tool allows users to upload point data from a shapefile, CSV, or Excel spreadsheet. So this is to help remove a heavy lift for those scientists that don't really have that geospatial background. The tool then converts this information into an ArcGIS online feature service, which does all the back-end data management throughout editing. And during this step, the tool adds 8 fields that are shown here. The 8 fields capture 3 different groups of information. On the left, you can see the 2 fields that show the verified location of the point. Then you have a few fields that represent the high-res address, and then the few fields for the NHD plus medium resolution as well. When a user is done with the tool, they can then export to a shapefile, but really that data exists in ArcGIS Online, so if you're savvy to using that, you can then export the data in a variety of formats or keep it right there in the feature service and hopefully share to the NHI concept that Al mentioned previously. Next slide. So I'll be going through a few quick slides just to show a few basics of the tool, but I highly recommend using our 6-minute training video to get all the details needed to get up and running with the Hydrolink tool. Next slide. Here's a general screenshot of what the tool looks like in editing mode. This can be accessed right after upload of your data. Notice the fields that I just mentioned are populated and showing as a default, but you can also add in and display fields from your data as well to help you navigate your different sites. Next slide. As mentioned, the tool allows the user to verify the location of the point and edit that if necessary. Here on the left shows a screenshot of data as it is uploaded by a user. You can see the point is off the stream, either bad GPS coordinates or the example I like to mention. I remember when I was doing field work, you know, maybe you forget to take that point while you're in the stream, but you take it back at a place where you're recording information or back at the vehicle location. So this gives users an opportunity to correct the accuracy of that point. And on the right-hand side here, you can see just with a general drag and drop method, the user can move that point and then get some immediate feedback to ensure that point is in the proper location. Next slide. And then the addressing component of the tool allows the user to get visual feedback to help evaluate a linear reference. So the tool works by allowing the user to click on the NHD networks. Both of them would be showing as default, but the user can click on the network and it'll drop a little square, as you can see in that image, to let them know where that point is being referenced. You can also do both of these simultaneously, so you drop one point and it'll try to get the address for both of those the NHD networks, but you also have the option to unselect one of the layers and just work one NHD layer at a time. This is helpful when you have two versions, or when the two different versions of the NHD have some high variability, or maybe one of the versions has a flow line where the others does not. Next slide. Alongside the web application, I've been developing a Python package to assist in addressing large sets of data to both versions of the NHD. This code is being developed in GitHub, and I encourage those that do use Python to help test and or develop these efforts. It's in an open space right now, and we also use fully open source methods, so there's no need for an Esri license to use this code. I'm currently working on some updates to help make the code easier to use and to expand methods and get better documentation and things like that instated. So if you do jump on there, expect to see some changes pushed into that repo soon. And the code also returns data to the users to identify how certain we are of a point being addressed to the right reach, just based on stream name, snapping distance, and some efforts we're looking into using distance to confluences too. Next slide. So at this point, I just wanted to remind everyone that everything Hydrolink can be found at this URL here. So the link to the tool itself, the Python code, and much more can be found at that URL. In addition, this space, when you go to that URL, encourages users of the tool to share their information to help it become more accessible and to help build on some of these NHI concepts that Al had mentioned. With that, I'll wrap up by noting that we've been working closely with the National Geospatial Program and the NG-Talk as well throughout the development of this tool. With those conversations, we are starting a longer-term strategy with them to eventually transition our users to the HydroAdd tool, which Mike Tinker will be talking about next. This will allow us to collaborate and support a common, more powerful tool moving forward. With that being said, those conversations have just started. And what we'll do is probably note that at this URL here as we know more kind of what that transition might look like. So it's still a ways out, but just wanted to make sure folks were aware of that. And with that, I'll go ahead and pass things off to Mike.
Okay, Mike, are you unmuted?
Yeah, can you hear me?
Yes, we can hear you. Great.
Very good. Hello, everybody. I'm going to talk about the HydroAdd tool today, the Hydrographic Addressing Tool. I'll show you a little bit about some of the thinking that went into it, and then I'll show you some screenshots to explain how it works so far. Next slide, please. So the overview of the HydroAdd tool is that this is a tool that allows users to address their data to the NHI high-res or maintain their existing HydroAdd data, what we know and love as events. The user, as Al mentioned earlier, and also with the Hydrolink tool, you have to make your data available as a web feature layer from ArcGIS Online in the HydroAdd schema. Once you've got your data up there in the right schema, then the HydroAdd tool allows editing of that layer. The user interacts with their data via an editing queue, and the editing queue drives the user to what are unapproved items. Queues, an editing queue is associated with a service layer. And one of the important selling points of this tool is that multiple queues can be associated with any one service layer, and multiple people can work on a service layer simultaneously. Editing permissions for those service layers are set in ArcGIS Online. So the user can search their service layer and select things to add to the queue, an editing queue, or they can select in the map just by drawing a box and selecting features, or they can select by hydrologic unit code. You can even search for your data by source ID. For example, a National Water Information site number, an NWIS site number, or a stream gauge site number. Using the interface, you can also search for a reach code or for WBD hydrologic unit. QC of a queue or an entire service layer is something that is also planned for this tool. Next slide, please. So the top use cases there are on top. First, users who have events that are already linked to NHC plus V2 or to the high-res already have existing reach codes. So especially if you've got stuff that's been indexed to NHC plus V2 and you want to migrate those to the high-res, that's one of the main reasons this tool is designed. Secondly, the national map has hundreds of thousands of point events, dams, flow alterations, stream gauges, WBD, hydrologic unit pour points that we need to maintain. And so that's the other main driver for this tool. But there are other use cases: maintaining stream gauges for stream stats database, addressing NWIS stream gauges so that you can attach reach codes to your stream gauges or any other NWIS holdings, to be able to attach any other kind of data to the high res, such as fish patches barriers or waterfalls like Daniel was mentioning. Culverts will be important as we move towards elevation-derived hydro. So Daniel and I speak frequently. SAS and NG-Talk will continue to collaborate on future use cases. Next slide, please. a general overview of what's been going on. In FY20, we've been building the editing queue for points, which is nearly complete. And we'd like to, in FY20, be able to QC people's points. And this is in progress now. In the future, these are essentially in priority order. In the future, it's important for us to be able to address lines and polygons. We'd like to be able to link the markup tool and the WBD tools to the HydroAdd tool. So for example, if you're a WBD editor and you need to make sure that your hydrologic unit pour point is in the correct place, zip on over to the HydroAdd, fix your WBD pour point, and then go back to the WBD editing. Or similar, if you see an issue in the NHD that you think needs to be addressed, zoom on over to markup tool, put a markup in, and then go back to HydroAdd. Longer term, as part of the NHI that Al was talking about, we'd like to be able to make all of our national map holdings available as read-only service layers and in-house as edit layers so that we can maintain them. And NHD plus high-res is coming. We want our tool to be able to address the catchments. And ultimately, it'd be nice to be able to actually share your service layers directly from HydroAdd for search and discovery. And again, the whole idea with NHI is for search and discovery of events, and that's what these tools are all about. Next slide, please. So I'll give you some screenshots here and so tell you how the tool is coming along. On the left-hand side, you see I've got a service layer, a couple service layers actually shared out on ArcGIS Online. You can see the map and the center image of the points as they live in ArcGIS Online. And then the lower image is the Hydro Address tool. The HydroAdd tool shows the same service layer as it lives on ArcGIS Online, but now it's being consumed by the HydroAdd tool and it's ready for editing. Next slide. So here I've got the dark gray background turned on. I've got the contours, national map contours turned on, and I'm zoomed into a particular point here. That's the NWIS site number. The source ID, 641, is the NWIS site number. And so what we're showing here is the search and select. So you can search for an NWIS or any, whatever your unique identifier is, the source ID, and I've just put in 641 and it zoomed to 641. Next slide, please. You can also do a direct selection right in the map just by drawing an extent. And here I've drawn a big box and I've selected all these features. The features are listed in the left-hand pane there that I've selected, and you can see the source ID, 4, 13, 14, 74, all the way down. You can also see that these are thumbs down. In other words, these are unapproved. These haven't been examined yet. Next slide, please. So once you've got a bunch of stuff selected, and I have select all here because I have a little checkbox at the top of the list. Once you've got a bunch of stuff selected, you can create a new editing queue, and that's what's happening here. I'm creating a new queue. Next slide, please. It asks you to name your edit queue, and it asks you to select your service layer. Next slide. And so now I've got a bunch of dots. It shows rows per page right now is 500. And so you can see all the dots that I have. There's 340. And they're all available in this list. And I've added them to this queue, which I've called the Four Corners State queue. And you've got the label there. But this is still just search and select. We've just added these to a queue. The next thing would be to actually start editing this queue. And you can see the queues listed there. Edit queues, Four Corners State. Next slide, please. So if we were now to go to the editing queue itself and select, you can have as many queues as you want, so you'd have your queue. The whole idea here is to drive the user to what is unapproved in your queue. If you mouse over a row in your queue, you'll get these buttons. The buttons light up. You've got the edit button on the left-hand side there. You've got the add or remove to queue button. And you've also got the delete from service layer. That's a rather powerful button. You can delete directly from your service layer. And then, of course, on the far left, you've got the approve, unapprove, thumbs up, or thumbs down button. And so you can click the road directly to zoom to that feature and examine it in the map, or you could hit the edit button itself to zoom to the feature and go directly to edit mode. Next slide, please. So here we are in edit mode, and you see the attributes. This is the HydroAdd schema, and this is you see important fields such as the source ID. The source ID is number 13 there. It's on the second row down there. And then you've got a reach code and a measure, which is like in the fourth row down. This has not been indexed yet, but as soon as we do, it's going to have a reach code and a measure and a reach spatial modify date. What you see in the map view is the cursor, and you see the snapping cursor, the cyan crosshairs. So wherever you mouse around in the map, the cyan crosshairs follow your mouse around, but the cyan cursor is always snapping to the nearest flow line in all cases. So if I were to click right now, wherever that crosshair is, I get a reach code and a measure, and it would fill in over the attributes there. Then user can go save their edits. The save button is up top. The only thing that you must have before you save is a source ID, a unique identifier. Once you save, next slide, please. The interface will drop you back into the queue. And once you've gone to the trouble to actually edit something and snap it and give it a reach code and a measure, the point is approved. As you can see, item 13 here, source ID 13 at the bottom of the list, and now has a thumbs up. So the idea is click a row, take a look at the point. If it's where it needs to be, approve it. If it's not, fix it, and it will be approved. Again, the whole idea with this editing queue is to drive the user to what is unapproved. Everything is about search and discovery with the NHI. And if the point is in the right place on the line with a reach code and a measure, then it will be discoverable by a stream trace. Next slide, please. Other thing I wanted to point out to you is the identify tool. Here I've drawn a box to identify NHD features. Actually, it will identify NHD features and features in your service layer. So here I've got hillshade turned on, and I'm drawing a box around some of these NHD features on the flank of Mount St. Helens. Next slide, please. And an attribute table opens at the lower part of the screen. This attribute table is broken out by NHD feature type. So I've got 23 flow lines selected in this box and a couple different water bodies. If you mouse over the row in the attribute table, the item is highlighted in the map. Next slide, please. Same thing, I'm mousing over a couple NHD water bodies that are shown on the map there. Next slide, please. Okay, that's it. Tool is still in development. Eventually, we're going to need beta testers. Please contact me if you're interested. Questions?
Okay, thanks, Mike.
You're welcome.
I'll just kind of reiterate that if you need to work on addressing data right now, you have two choices available to you. You have the HEM tool, which still works. It's a desktop GIS-based tool, and Mike is our support person for that. And you have the Hydrolink tool that Daniel showed a few minutes ago. And then in the near future, hopefully, we'll be able to release this tool to the public that Mike was just showing, and you'd be able to use the HydroAdd tool. So I'm going to go ahead and turn off mute for everyone. Hopefully it's not too noisy. And we have just a couple of minutes here if we have any questions. Does anyone have questions?
So this is Anna from Missouri, and I was wondering, the HydroAdd tool, is that strictly for points, and is it going to be expanded for lines and polygons in the future?
You just said it was.
Yeah, we would like to make lines as a big part of what HydroAdd is that's for future development. We're starting with points, but we'll get to lines and polygons too.
Okay, sorry that I missed that point.
Okay.
Okay, other questions? Well, okay. So that's great. I think we will conclude with this. Thanks everybody for joining us. I hope everybody stays safe. And we'll have another advisory call next month, our regular time. Thanks again, everybody, and we'll see you next month.
Thank you. Bye now.